I continue the next lecture, Alkane characteristics, where you have seen and learned tetrahedral structure of alkane, methane, which produce angle 109 degree and 28 second. Now, the next characteristics of alkane is all the carbon atoms are co-linkage by the single covalent bond and produce a long chain. Next characteristics of alkane is it shows the catenation properties. Discuss about the catenation. Catenation is the properties of carbon atom in alkane that produce a long chain due to co-linkage between the carbon atom, as carbon added to another carbon and so on. This linkage between carbon and carbon by the weaker bond to make a long chain of carbon atom is called catenation. Next, carbon produce a homologous series. Then here is the question that what is homologous? Logous series. A group of alkanes or an organic compounds which is in successive order to produce a difference of bond CH2 for making a long chain. For example, CH4 methane, C2H6 ethane, C3H8 propane, C4 H10 butane C5H12 is pentane. Here is the difference between successive to the predecessor, successor and predecessor by the difference of bond CH4, bond CH2, and here the second organic compound, when differ by the propane, it also produce bond CH2 similarly in all the successive. Here such type of differences between the successor and the predecessor in an organic compound of hydrocarbon is said to be homologous series. Same difference between the successor and the predecessor, so it is called homo. Next, the hybridization of alkane. Alkane means CnH2n plus 2. Alkane means CnH2n plus 2 that produce as a first member methane, second member ethane, fourth member propane, sixth member butane, and fifth is pentane. The hybridization of alkane is sp3. Very important, this homologous and the hybridization of alkane. You should have remember always for the next coming examination as the competitive view to take a high score. Next, non-organic compound or hydrocarbon is only 4, that is CH4 first member, that is called methane, second member C2H4 6, that is ethane, third member C3H8, that is propane, and C4H10 that is butane. The nomenclature of such 4 compounds is not on the basis of number of carbon, because according to number of carbon, this name methane, ethane, propane and butane are not made, but it is the non compound from the organic compound of hydrocarbon, because if n equal to 5, then compound made is C5H12, known as pentane. According to number of carbon 5 is penta, so it is known as pentane, but these 4 are not on the basis of number of carbon. N equal to 6, that is C6H14, hexane. 7, that is heptane or septane. 8, octane. 9, nonane, but and so on. 10 is called tenane or dencane. These are basis on the number of carbon, except these 4, because these 4 are the non-compound that can be invented. Next, so we knowing all the other characteristics of alkane as per C1 to C4 means methane to butane are gaseous state. C5 to C15 are in liquid state. And above C15 are solids. Alkane produce isomers. Here the question, what is isomers? Isomers. The organic compound which have similar empirical formula or molecular formula, but their structural formula are differ regarding with their physical and chemical properties are also different. Such compound is called isomers, and the phenomena of this process is called isomerism. For example, C5 H12. Remember here and be attentive. We have to study about the open chain. Open chain, that is a cyclic hydrocarbon, in which we study about the open chain that produce a long chain between the co-linkage of carbon atom by the covalent bond. And we also study about the open chain. There are three types of structure. One is neo chain structure, second is iso chain structure, and third is normal chain structure. At first we clear about the normal chain structure. If the bonding between the carbon atom produce a straight line and make a long chain, that is called normal chain. In this way, either you, according to number of hydrogen, you must write it in the same order. That is, normal number of carbon is 5, so it is called pentane. Pentane. It is called normal chain structure of the pentane. Second chain in open chain is called iso chain. Iso chain is also known as branch chain. So we can write pentane in this way. Or it is just a structure of branches of a tree in which one or more than one carbon atom is lifting with the or hanging with the another carbon atom. So it is called iso chain. Another example of this open chain is known as another structure of the pentane in open chain is known as neo chain. Neo chain. Carbon and carbon are co-linkaged by the single bond, and two rest carbon are also linkage with the any of the carbon, either of. It may also designing as C in this way. These are the neo chain. I define it neo chain, an organic compound of hydrocarbon in which the carbon atom are co-linkage with any of the carbon as a branch ups and down with any of the carbon atom. It is called neo. Alkane produce a radical, as you have observed this mechanism that qualify a compound of alkane has only such properties that produce a radical. Radical, you have attentive for this mechanism. Alkane minus ANE plus YL, that is called alkyl. Here alkyl is the radical of alkane. You have also studied the GF of alkane is CN H2N plus 2. In place of alkane, we write 1H that produce CN H2N plus 1. It is the GF of alkyl radical. It is the GF of alkane. Suppose AN, the suffix of alkane, means alkane ANE, the suffix is to 1H. So in alkane AN is substituted by the alkyl. When we replace AN and add YL, then it produces alkyl. A radical of alkane is alkyl. Here according to GF CnH2n plus 2 1H AN equal to 1H is when substituted replaces, not substituted, replaces from the CnH2n plus 2, it changes into CnH2n plus 1. So GF of alkyl is CnH2n plus 1, a radical. CnH2n plus 2 GF of alkane, it produces a saturated hydrocarbon. Here alkane is saturated, but alkyl is unsaturated. Here alkane is unactive for the chemical reaction, where alkyl is active for the chemical reaction, because you have to study here, listen and observe. CnH2n plus 2 if n equal to 1. You know the outermost electrons of carbon is 4, combining with other 4 electrons to make their octave. So n equal to 1 means CH4 methane. When it replace 1H, then it get converted into CH3 bond. Here is the bond, means 1 electrons, 1 electrons, 1 electrons, 1 electrons. Follow. Combined with 1H, 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 1H. When we replace 1H, then such electrons are detached from the methane and make here in this way. In this way. Counting here, 2, 2, 2, 2 means 8 detaching of 1H with their cross electrons. Then here is the electron number of electrons is remain 2, 2, 2, 1, that is 7. Need of 1 electrons to complete their octave. So therefore, we can write here, methane detaching of ANE plus YL produce methyl as CH3 bond, but here is methane is CH4. Another ethane, that is C2H6, when detaching ANE, adding of YL, it produce ethyl C2H5 bond. These are the radical and active to take parts in a chemical reaction. The radical of alkane also produce a homologous properties as you see CH3 bond, C2H5 bond, C3H7 bond, C4H9.